Okay, 1b में you have 1 minus tan square a, and you have to prove that it is same as cos 2a times secant square a. Acha. Sometimes it is really handy to see that what is this right hand side showing. So I'm just going to simplify a bit the right hand side. So this is cos 2a over cos square a. And now you have the forms of cos 2a over here. So any one of these three forms can be there in the numerator. Okay, now let's start from the left hand side. You should always say left hand side whenever you're proving the identity, if you're starting from the left hand side. So this is quite clear to me that I'll be writing this tan square as sine square a over cos square a. I have no other option than taking the LCM here. And the moment I take the LCM, I see that I have obtained the required thing. Here it is. You see this cos square a minus over here, this, that is your cos 2a, and you have already got this cos square a in the denominator. So I'll change this with the cos 2a, and this is my cos square a, and I can write it as cos 2a times secant square a, and that is my right hand side.
सर अगर हम इसको राइट हैंड साइड से सॉल्व करते तो फिर कैसा होता? मैं राइट हैंड
Choice
साइड
is
ले रही थी.
choice is all yours. You just go backwards. Go like you start from here, and then you uh, open this cos 2a, and then you split them, and then you go back to this form 1 minus
Can
tan.
you solve it from the right hand side as well? Because when
It
I was
is it
doing, I
is
was
there,
getting
but
cos
look at this. Suppose I have started like this. No, this is the right hand side over here. Okay, this is your right hand side. Okay. I'm going to shift this secant square down. This comes down here. Now I'm expanding this cos to a, this which becomes cos square a minus sine square a. Then I split it. Cos square a over cos square a gives me 1. And then sine square a over cos square a, which can be written as tan square
No, thank you.
a. Okay. So this is 1D. I'm just writing the right hand side far away so that I can just manage some space over here. Okay. So you see that there is 5 minus 4 cos 2a plus sine 2a. If you look at this, this is going to be your cos 2a is again, it can be any three of these. And your sine 2a is 2 sine a. Sorry, there's 3 sine 2a. Sorry, there's 3 sine 2a. So sine 2a is 2 sine a cos a. Let's see what do we get. I think this seems to me that this would be an easier identity to prove. This is going to be cos square a plus 6 sine a cos a plus 9 sine square a. Okay? Then he has taken this as minus. There is minus. So I think he has chosen, yeah. Okay, let me see. This is going to be, if I change the sine square a with the 2 cos square a minus 1, I don't get this 4 cos 2a. If I change that with 1 minus 2 sine square a, I have 9 minus 18. Okay, let's try this. This is cos square a. Okay, and then I should have the sine square a thing with me. I'll be picking one. Uh, just a minute. Yeah, because I have to have five. Kidhar gaya? Yeah, we have five. Okay, so it means that there should be 5 cos square a, and then 5 sin square a. Okay. As a cos square a, I'm taking 1 sin square a from here so that I have at least 1 with me. Okay. Then I am left this can clearly be written as 3 sine 2a, because this is going to be 3 times 2 sine a cos a. Then I have this 8 sine square a. Okay. This is 8 sine square a. Okay. Yes, I think I have reached where I wanted to be. This is, you see, I have broken this 9 sine square a into sine square a plus 8 sine square a. And I have written one of the sine square a with the cos square a. Now this becomes 1, okay? And this is going to become 3 sine 2a, okay? Acha, 8 sine square a. 8 sine square a. Okay, we have the rule, we have the identity that 2 sine square a, oh, this is so not clear. 2 sine square a is 1 minus cos 2a. Okay? So I am going to change this into this 8 sine square a. It means 4 times 2 sine square a. है ना? And instead of 2 sine square a, I'll be writing this. So I have plus 4 minus 8 cos a. Yes. Uh, sorry, 4, sorry. It should be 4 because it is 1 minus cos 2a. I'll be multiplying that by 4. So I have 4 minus 4 cos a. Finally, I have got what we wanted. This 4 plus 1 becomes 5. And then we have
Sir,
3. Yes, yes. Just a minute. Let me complete this. And then we have
सर मुझे
minus.
एक चीज़ बताइए आपने 5 कहाँ
Mhm. Uh-huh. Yes.
सर आपने उसे 4 cos a कैसे बना दिया?
अरे यार, where it is 4 cos a? This is 4 cos 2a. I'm sorry.
सॉरी सर, जी वही।
4 cos 2a. Thank you for mentioning that. This is 4 cos 2a. Because yeah, देखो ना, if you have there are basically this your cos 2a identity is very important, बच्चों देखें. If you see that this cos 2a is basically cos square a and then minus sine square a. Okay. And then this is written like, if you change the cos square a with 1 minus sine square a, so you have the same as 1 minus 2 sine square a. Okay. And then you have a 2 cos square a minus 1. And in your integration, which is going to be coming up, you will have to remember these rules by heart, that if you have 2 sine square a, that is 1 minus cos 2a. And if you have 2 cos square a, that will be 1 plus cos 2a. Okay? So uh, I had 8 sine square a over here. Okay? So I changed that into 4 times 2 sine square a. And then this sine 2 sine square a has been changed with the 1 minus cos 2a. So 4 into 1 will give you this 4 and minus 4 cos 2a over here. You were asking that how did I get to this 4 cos 2a? So this is basically 4 into 1 minus cos 2a. I get this 4 minus 4 cos 2a that I have written here, over here. Okay, this is your
Sir, can
4.
you do part C?
Yes.
Part C.
Okay, so is this clear? You see how much you have to manipulate the things and how much exercise your brain would be having when you're going to change something given in one form, changing into another form, using all these tools which are written here on the right hand side. What is the next part you want? The C part?
C part.
Okay,
C
just wait.
part.
So I'm telling you an alternate way to do this, like from this onwards. Just look at this. I just, this struck my mind. Look at this. Okay. The thing is that I need a 5 here. Okay. So when I need 5 here, so what I will be doing, just let me remove this. Okay. Now, okay, I need to have 5 sine square A and 5 cos square A over here so that I can have 5 here. Okay. So I'll add 4 more cos square so that I have 5 cos square A with me. And I'll write here minus 4 cos square A because I have taken 4 extra cos square A over here. Okay? I'll take 5 sine square A from here. This is 5 sine square A. And I'll write the remaining 4 sine square A over here. Look at this, how cool it is. Oh, yes. And then we are quite sure that we can write this as 3. There is no problem with this. This is 3 sine 2A. Okay? Now, you will take 5 common from here. You will have 5 into cos square A plus sine square A. Yes. Then I'll just keep writing this as 3 sine 2A. Well, let me take minus 4 common from here. If I take minus 4 common from here, this would be minus 4 into, oh yes, this is easier, cos square A minus sine square A. So this becomes, you see how cool it is, minus 4 cos 2A. So I have done the same thing with an alternative method. You see, there are so many ways to prove the same identity. And now we are into the C part. I have written down the right hand side, the far right side of this. This is tan 2A minus tan A should be tan A secant 2A. Just trying to manipulate a bit, simplify a bit this right hand side. And you have cos 2A over here. Okay. So cos 2A would mean any 3 of these forms. Okay. So this is your left hand side. So starting from here, so we have sine 2A over cos 2A minus yes, minus sine A over 9. I think I should use the tan 2A formula here. Yes. Okay. So I would rather be writing this because see, I was looking at this tan A. So this has struck my mind that if I, instead of writing this as sine 2A over cos 2A, if I write it as 2 tan A over 1 minus tan square A, and then I have minus tan A. Okay. I can take tan A common from the numerator. Look at this. I have tan A taken common from the numerator so that, you know, this is managed. The only thing I have to show that is 1 over cos 2A. Okay. Now this is going to be 2 over, let me write this as 1. So let me write it as it is. Okay. And we are left with minus 1 over here. ठीक है बच्चों, are you with me so far?
Yes.
अच्छा, 1 minus tan square A जो होता है, that is 1 minus, just to manage some space, I'm writing it here, the denominator. Okay. If I take the LCM, this becomes cos square A minus sine square A over cos square A. Yes, this is like this, है ना? क्यों बच्चों? ऐसे ही है ना?
Yes,
I
sir.
take the LCM, this becomes cos square A minus sine square A over cos square A. Since this 1 minus tan square is down in the denominator, so when I write it here, this becomes tan A into, this will go in the numerator, 2 cos square A over this cos square A minus sin square A minus 1. Yes, बच्चों?
Yes.
है ना? अच्छा, if I take the LCM now, you will see that what will I get? Let me cover this up and I should write it here. Now I'll have, let me write it here. Now this is going to be tan A into, this is 2 cos square A, and I have minus cos square A. Be aware of your signs, and then I have plus sin square A. Okay? That is over this cos square A minus sin square A, and I can write it as, um, can I write it as cos 2A if you don't mind? Hmm?
Yes.
Yes. Now look at this. What is 2 cos square A minus cos square A? There is cos square A, and then you have plus sin square A, which gives you 1 in the numerator. So skipping some steps here that you must show, this becomes this, which is your right hand side. And all of this becomes 1. And 1 over cos 2A is going to be secant 2A. This might look like a very difficult task to you, lekin if you practice these, you will,
Sir,
once you're used to these identities, this can be easier for you. Yes, beta.
सर मुझे ये वाला स्टेप नहीं समझ आया जो आपने किया tan है और फिर ब्रैकेट में 2 cos square है minus cos square है ये वाला कैसे
Look at
आपने
this, beta.
किया?
I have taken LCM over here. I have taken LCM in this over here. Okay. If this is your LCM, this 2 cos square A will be written here. And then minus 1 into all of this. Minus 1 into cos square A, I written here. And then minus into minus plus sin square A, I have written it here. Got it?
Okay sir.
Okay.
Yes sir.
Okay, that is it from this segment. Let's come back for the second session.